This is chapter 6, problem number 38. The lucky number for this problem is 6, number 6 here. All right, this person, he's jumping down to the trampoline, okay, with an initial velocity of 4.5 meters per second. Okay, so the first thing that comes to our mind is, actually, it doesn't matter if he jumps up or jump down with that velocity. Why? If he's jumping up with 4.5 meters per second, guess what? At some point, he's going to stop and fall back down. And once he reaches back here, then it will be 4.5 meters per second. Okay? That means, in any case, he will be jumping down with that initial velocity anyway. All right, so over here, the moment that he just jumped down, he has both kinetic energy and potential energy. Once you jump down over here, first of all, does it stop right away? Probably not. Probably we go a little bit down into it. Okay, so at the end, when he stopped, what will happen? He convert all the kinetic energy. Well, there will be kinetic energy. There will be potential energy due to gravity. And there will be also potential energy due to the trampoline, because we can treat the trampoline as a spring. Okay, so of a spring. Okay, over here, we can also put the potential energy of a spring, potential energy of a spring, okay, potential energy of gravity. So over here, potential energy of the spring will be equal to 0. Why? Because it's not stretched or compressed. Kinetic energy, it will be half mv squared. Okay, so over here, potential energy, okay, if we call this one 0, then it will be mgh. However, when it comes over here and move a little bit, okay? All right, so let's look at two different things, okay? If we want to see the speed at over here, with just right before it touched the trampoline, see what it is, okay? So potential energy in this case will be 0, because I call this 0 over here. Okay, so, well, in fact, it's mgh. However, the h will be equal to 0 over here. Okay, and that will be equal to kinetic energy half mv final square plus the potential energy due to gravity plus the potential energy due to the trampoline. Let's say right before hitting it, so it's 0. Okay, so how do we do this one? We just have to plug in all the numbers. Over here, initial velocity is 4.5 meters per second. Now you may ask, should it be positive or negative? Actually, it doesn't matter. Why? Because we are going to square it. That if it's positive, then the square will be positive. If it's negative, then the square will still be positive. All right, so let's look at this. We can cancel the m everywhere. Okay, that means it will be independent of the mass of this person. Okay, so 62 kilogram, when you jump right before hitting the trampoline, it will be independent of the mass. Okay, so what I'm going to do is, it will be half times v initial square, that is 4.5 square, that would be equal to, plus g, that is 9.8 times 2, that will be equal to half times v final square. All right, I'm going to use my calculator. I just have to put in everything. So on the left side, it will be 4.5 square divided by 2 or multiplied by half is the same thing. Oops. All right, let me try that again. It is 4.5 square divided by 2, and then I plus 9.8 8 times 2. So on the left side, I have 29.7. So I multiply that by 2 and then take a square root of it. All right, 7. So what I get is V final is equal to 7.71 meters per second. Okay, so right before it hits over here, it will be 7.71 meters per second. All right, now the second part. So how much will this person get into the trampoline? Okay, so when it touch here, it's going to stretch and get down and then recoil back. Okay, so over here, we know the initial, we call this my initial velocity. And once it reached the bottom, okay, so it will convert most of the kinetic energy into potential energy. Okay, so let's write it again. So I have both kinetic energy and potential energy. I'm going to erase this. I am going to call over here, right before it hit the trampoline, that's my initial stage. Okay, and at the end, when it stretched, okay, when it stopped, I call that my final stage. So initially, potential energy over here, let's say it will stretch delta x over here. Okay, so I'm going to call this my 0. Okay, so this is not 0 anymore. This will be my delta x over here. So due to the spring over here, initially when the trampoline is not stretched, that means it's 0. Kinetic energy is equal to half m v square. Okay, v final square. This v I'm going to plug in. Okay, m, I'm going to put everything in. Okay, half m is 62 kg. V is 7.71 meters per second. Okay, so potential energy plus kinetic energy plus potential energy due to gravity. Okay, that will be plus m 62 g 9.8 h, that is delta x. Okay, that's right before it hits the trampoline. Okay, it will be equal to, it will convert everything. Okay, so what is the kinetic energy when it stretched and stopped? When it stopped, it will be 0. So kinetic energy is 0. Potential energy due to gravity, we move from delta x here to 0 here, it will be 0. Okay, potential energy of a spring will be equal to half times k. K in this case is 5.8 times 10 to the 4th over here, newtons per meter, times delta x square. All right. So what I need to do now is I try to solve for delta x. Okay, so you have one equation, you have one unknown. We should be able to calculate for the delta x. Okay, so I would like you to do this exercise. I would like you to solve with one unknown in this equation. So this is already a constant. You plug into your calculator, you get a constant here, you get a constant here. You cannot easily cancel the delta x. See, you have a square here, you have the first power here, but you cannot cancel it because you don't see the delta x here. So it would be a quadratic equation. When you have a quadratic equation, for example, you have a x squared plus bx plus c equal to 0, then x will be equal to negative b plus or minus square root of b squared minus 4 times a times c divided by. Okay, all right, so you are going to do that exercise, but the physics part is conservation of energy. Once again, the lucky number for this problem is 6.